This is the bebop in its final configuration. We've had to go back to the foam that we mixed. Here's Bert, who is adding another float to our gadget so that we can see if we can get the bebop level and neutrally buoyant. He's having trouble finding way to get another float on there. So we take it out in the water at Yellow Submarine. In the Yellow Submarine, we see how it floats. It looks pretty good, doesn't it? Yes. It's a great place to dive, by the way, Yellow Submarine. There's some right out underneath those boats. There's these big blocks with Sergeant Blenny's popping out. There's a jawfish right there.
Keep them right. Keep them going.
There we go. We're putting the bebop in the water. You got to be careful because I don't want to hang up on any of the floats, and I certainly don't want to damage any of the instruments. Kind of nice, this boat with that open hatch, and Bert now has it in the water. Now what he's going to do is he's going to do a final buoyancy test, and it looks to me like he's going to need some more floats because it doesn't look level. We don't like non-level. Alright, there we go. There's another float which he's going to put on the low side to try to level it off. It's not that easy to do in the water, let me tell you. Alright, we're success. We're going underwater. It's going down. Bert's popping up. That means one of the volunteers, is taking it down.
That was the weight belt.
Here we go. Here's Lewis taking it down from the boat. The goal is to position it at the same depth as a rainbow sensor array. The whole goal in the first step is to use the radiometer, which is right on top of the bebop, to measure the downwelling light and compare that with the measurements from the rainbow sensors on the LMSP arrays. We also have rainbow sensors on the bebop itself, so we can do two readings. And he is going to take his time. Notice that bubbles. He's got to get out of the way. Those bubbles can mess things up. Doing pretty well. Yeah, he's getting it pretty close. That's actually close enough. Within a meter or so is as good as you can expect to get. He's going to now change the buoyancy with a lift bag. Looks like it's a little heavy. There we go. We got it positioned. Notice it isn't completely level, but it's pretty good. The lift bag threw it off because only could have the lift bag on one side, but you can see the LMSP array and the bebop pretty close to the same depth. Alright, let's take a good look at this thing, and you can see the lift bag. We used that to change the buoyancy because the foam did not really incompressible the way we wanted it. You need syntactic foam to do that. This was another kind of a foam, which was pretty good, but didn't do it all. Right there on top, that round device, as you'll recall, is the radiometer. 7 channels. That's what we're doing right now in this half hour. We're looking at the downwelling light at the 3 depths of the array, and we're going to see how accurate our rainbow sensors are. Coming into view now, off to the right there is a white tube. That's a CDTD, conductivity, temperature, and depth. That actually allows us to know exactly what depth we're at. Also tells what temperature we're at, which is something else a rainbow sensor mentions. And it'll measure, the conductivity measures the actual salinity of the water, which is going to be kind of interesting to look at. You see the blinking there? That means that we're collecting data. That big thing is the batteries and the data collector for the device. Last minute change, which was really important. I don't think we could have done it the original way, powering this from the boat. It was just too hard to maneuver. Alright, let's look at the bottom here. I can see the fluorometers on the bottom. There we go. There's the fluorometers. Emitted light. Remember, it's fluorescent light, not emitted light, that we measure. And here we are back again, giving a good look at the rainbow sensors on the moorings of the LMSP and the positioned bebop. Probably it looks like at a lower depth where we're spending another half hour. After this, we go up and down 10 times to try to measure different things. Here we go. This is a picture of the rainbow sensor. This is our last underwater shot because we lost the camera flooded, but we do have another with the still shots of the reef on our next video.